So today we're going to graph the example y is equal to x squared minus 6x plus 5. We're going to start by labeling our a, b, and c. Our a value is 1, our b value is negative 6, and our c value is 5. Now we can move on to our axis of symmetry. To find our axis of symmetry, we use the equation x is equal to negative b over 2a. When we substitute in the a and b, we get negative 6 over 2 times 1. This is going to simplify to 6 over 2, which is equal to 3. So x is equal to 3 is our axis of symmetry. Now remember, the axis of symmetry splits the graph down the middle, and it is also where our vertex lies. Our vertex is a point, right? Remember, this is a point, and we know that points are written as x comma y. So right now we only have the x. We need to find the y value. We can do that by taking this x and substituting into our original. So now I'm going to have y is equal to 3 squared minus 6 times 3 plus 5. And let's simplify. We have 9 minus 18 plus 5. Simplify again. Negative 9 plus 5, and that's going to give me a negative 4. So the y is equal to negative 4. So the point, the vertex, is the x value, which is 3, and the y value, which is negative 4. Now we can move on to our y-intercept. What do we know about a y-intercept? If something is a y-intercept, that means it lies on my y-axis, and x is equal to 0. So just like we took x here and substituted to find the y, we could take x is equal to 0 and substitute to find our y-intercept. Or we can use our shortcut, which we know is that the y-intercept is always 0, c when we're in standard form. So with that, we know that the y-intercept is just 0, 5. And if you plugged in, you would get the same answer. If you plugged in x is 0, you would get the same answer. So if you want to do that to check, you can. Let's move on to the x-intercepts. The x-intercepts, well, the opposite, they lie on the x-axis, so now the y is equal to 0. So we take our equation that we have, we set it equal to 0. So 0 is equal to x squared minus 6x plus 5. Now in order to solve this, we either need to factor, use the quadratic formula, complete the square. If we look quickly to see can we factor, we notice, yes, we can factor. We can get numbers that multiply to 5 and add to negative 6. So we can write our parentheses. We know that those magic numbers that will multiply to positive 5 and add to negative 6 are going to be negative 1 and negative 5. And remember, this is equal to 0. So now we can split up these parentheses. We can do x minus 1 equal to 0 and x minus 5 equal to 0, and we can solve. We get x is equal to 1, and we get x is equal to 5. These are my x-intercepts, right? So if x is 1 and y is 0, this is the point 1, 0, and this is the point 5, 0. So now that we have our key features, our axis of symmetry, our vertex, our y and x intercepts, we can start graphing. Our axis of symmetry was at x is equal to 3. So 1, 2, 3, and it's going to be a vertical line through the value x is equal to 3. Our vertex was 3, negative 4. So x is still 3, and now we go to down y, negative 4, so that's going to be the point right here. That's my vertex. My y-intercept was 0, 5, so x is 0 and y is 5. 1, 2, 3, 4, 5. And my x-intercepts were 1 and positive 5, so x is equal to 1 and x is equal to positive 5. Now remember, this is the mirror part, this is the reflection. These x-intercepts should reflect each other, and they do. They're both 2 spaces away from my axis of symmetry. And now we can also reflect this y-intercept. So this is 1, 2, 3 spaces away, and so it needs to be 3 spaces away in the other direction. 1, 2, 3, giving me this point here, which is 6, 5. Now I can tell that my graph is opening upward, and so I'm going to make this U-shaped curve here. This is my parabola, right? It's not the best. We can kind of fix this over here a little. It's a little bit better. How else did we know that this was opening upwards? Well, we can remember that A was equal to a positive value, so therefore this would be opening upwards, making this vertex our lowest point or our minimum, right? And now our domain, we can pick any x values, right? So domain is all real numbers. And our range, well, are our values higher or lower than our vertex? Well, clearly our values are above our vertex. And now remember, range represents the y value. So you need to look at the y coordinate of your vertex, which was -4. And we said that the values are higher, so they are greater than or equal to -4. And now all together, we have our full process here. We labeled A, B, and C, found the axis of symmetry, found our vertex, found our x and y intercepts, graphed our points, and determined if it was a minimum or maximum and what the domain and range was. So in this example 2, we're going to graph y is equal to x minus 3 quantity squared minus 4. If we notice, this is in vertex form. Vertex form is y equal to a x minus h quantity squared plus k. So let's start by labeling our a, h, and k. A is equal to 1. In the equation, you can see it's written as minus h. So this is minus, and that means whatever is here is h. So h is 3, right? So we can kind of think of it like if this is -3, well then h is actually the opposite of that value. And k is -4. Now, we said this is vertex form, so this is supposed to give us our vertex, and it does. Our vertex is our h, comma, our k value. Now, if you remember, the axis of symmetry was whatever this x value was here, and so the same applies. Axis of symmetry is x is equal to h. So our axis of symmetry is 3, and our vertex is 3, comma, -4. And it really is that easy if you use the formula correctly. Now, for our y-intercept, this is where we have to do a little bit more work. There is no shortcut like in standard form, but it's not too difficult because we know that if something is a y-intercept, then that means that x was equal to 0. So we can take our equation and plug in 0 for x and solve for y. So y is equal to 0 minus 3 quantity squared minus 4. And this is y equal to -3 quantity squared minus 4. Simplify again, 9 minus 4 is equal to 5. So y is equal to 5, x was equal to 0. So this is the point 0, comma 5. And we have our y-intercept. Now to find the x-intercepts, similar concept, we're going to now set y equal to 0 instead. And so we have now 0 is equal to x minus 3 quantity squared plus, minus 4. And now this is not in standard form, so we can't use quadratic formula or factor here. But we do notice that we only have one x term, and it's being raised to a power of 2. So we can use our square root shortcut here. Get x by itself and then take a square root. So we'll start by moving this 4 to the other side. That's going to give me 4 is equal to x minus 3 quantity squared. Now to get rid of a power of 2, we can take a square root. So this is equal to plus or minus 2 equal to x minus 3. Add 3 to both sides. And so this is x is equal to 3 plus or minus 2. And now to split that up, x is equal to 3 plus 2. and x is equal to 3 minus 2. This is going to give me 5. So x is 5 and y was 0. That's the point 5, 0. And this is equal to 1. So x is 1 and y is 0. This is 1, 0. Now, this looks awfully familiar. We have an axis of symmetry of 3, a vertex of 3, -4, a y-intercept of 0, 5, and x-intercepts of 5, 0, and 1, 0. If we look back at example 1, we had all the same values. We had axis symmetry of 3, vertex of 3, -4, y-intercept of 0, 5, and x-intercept of 1, 0, and 5, 0. So example 1 and example 2 were the same example, just in different forms. So this graph should look exactly the same. I already did it for us. So we have axis of symmetry, our vertex, our y-intercept, our x-intercepts, and our reflection. We already know this was a minimum. We know this is all real numbers. And we know that the range was greater than or equal to -4. So I'd like you to take a minute, look at these two examples side by side. Notice how they are exactly the same. Example 1 is written in standard form, and example 2 is written in vertex form. So depending on how your quadratic function is given to you, which form, determines how you will approach solving and graphing the question. So now take a minute, pause the video, and look at the similarities.